So we're going to talk about square and square roots. Before we do, let's quickly review what an exponent is. So if I have a 2 here, a 3 here, the 3 is called the exponent, the 2 is called the base. Okay? And this is all called, right, all of this, that's called exponential form. Okay? Oops. Exponential form. Okay. So what is it saying? Well, it's saying that you're going to take this 2 and you're going to multiply it by itself 3 times. 2 times 2 times 2, which equals 8. Okay? All right. So, moving on to squares. So what is a square? A square is this. This would be square. This would be square. This would be a square. Oops. Sorry about that. Let's try that again. This would be a square, and this would be a square, okay? So that's 2 squared, that's 3 squared, that's 4 squared. And just like with this one, you're going to do this, the 2, and you're going to times it by itself 2 times, 3 by itself 2 times, 4 by itself 2 times. So 2 times 2, 3 times 3, 4 times 4, okay? So if you had a 5 times 5, right, you could rewrite that as 5 squared, okay? Now, say you had a number such as 49, okay? This is where we're moving on to square root. All right, so you have 49 and you want to know if it could equal something, right, times by itself. All right, so the way you'd write that is you do it like that. That means the square root of 49, okay? And if you didn't know what that was, you'd have to do trial and error. So say, 2 times 2 is 4, and 3 times 3 is 9, and 4 times 4 is 16. It's still not 49. Then you'd go, okay, 5 times 5, what's that equal? Well, that equals 25, okay? And then you do 6 times 6, and that equals 36. Still not quite big enough. So you go, okay, well, if that's not big enough, let's try 7. And lo and behold, 7 is 49. So the answer to this question would just be 7. Okay, that would be the answer. So the square root of 49 is 7. Okay? All right. So let's take this concept further. Okay? All right. Say we have a square here. All right. Assuming that all of these sides, this is a perfect square, all these sides would be equal to each other. So if this was a 2 and this was a 2, then this over here would be a 2 and this would be a 2. Now, what would be the area inside? Well, the area would be inside, if this is 2, right, say it was 2 inches, then there'd be 1 inch, and then there'd be 2 inches. So 1 inches and 2 inches. And then if this was inches as well, 2 inches, then there'd be 1 inch and then 2 inches. So you'd have like that, okay? And the area, it would be how many inches are inside of this box, of this square, okay? So it'd be 1 inch, 2 inch, 3 inch, 4 inch. So the answer would be 4, all right? Well, that's the same as taking 2 times 2 equals 4. 2 times 2 equals 4. Well, let's see if that works with a bigger one. So say it's another perfect square, and it's 3 inches on this side, and 3 inches on this side, okay? Well, that's going to be 1, 2, 3. So 1, 2, 3. I know it's not perfect. We don't need perfect. All right, and then again it's going to be 1, 1, 2, and 3. So it's the area. Well, let's look at it. 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, 6 inch, 7 inch, 8 inch, and then 9 inch. Well, that's the same thing as 3 times 3 equals 9. And 3 times 3 can be rewritten as 3 squared. Just like this can be rewritten as 2 squared. Okay? So when you have a square, to find the area, it's just A equals side squared. Because even though I didn't put a 3 here, and even though I didn't put a 3 here, I don't care about those sides. I don't need to worry about the sides. I don't need to worry about writing those sides because I know they're going to be equal to these sides. And therefore, I can take this side times this side, okay? Just like I did here. And it's going to give me the area, okay? So again, let's say that one more time. 3 times 3. Well, this is a side, and this is a side, okay? 3 equals a side. All right, so I'm defining the area. I'm just doing, I'm doing side. So in this case, area over here would equal side times side. And then what does this side equal? And this side equal? It equals 3. So 3 times 3, and that equals 9. Okay? And you can rewrite side times side as side squared. And that's why the area of a square is side squared. Okay? So let's take this concept further. Remember we talked about square roots a second ago? Let's talk about that one more time just real quick. Say I had a 4, and I want to know if something times itself equals 4. Well, the way I'd write that is the square root of 4. That's how you do it. And then I would, if I didn't know the answer, I would do 1 times 1. That equals 1. 2 times 2. Well, oh, look at that. That equals 4. So the answer to this question would be 2. Okay? And we just learned how to find the area of a square. All right? It's side times side. So now let's take that concept a little bit further. So say we have a square such as this. All right? Let's say it's a perfect square. Okay? And say we had a 49 inside. All right? Now if we have a 49 inside, that's the area of this square. Okay? That's the area of the square 49. All right? Well, if that's the area of the square, and we know that the area of the square equals s squared, or side times side, right? Then the question at hand is, what is the sides of the square? What is the side? What's the length of each side? Okay? And we'd have to just do trial and error if we didn't know. In this case, we know. I know. It says 7, right? So it'd be 7 times 7, okay? Or 7 squared. All right? 7 squared, okay? Now, let's also just do a real quick review on what a whole number is. A whole number would be 0, 1, 2, 3, 4, 5, and so forth, and so forth, and so forth, okay? Those are whole numbers, okay? So, if you were asked to determine if the area of a square has a whole number length for its side, you would basically be determining if the square root of the area of the square gives you a whole number. Okay? In this case, it does. So let's say that I'm not going to draw a box. Let's say we had a box, or a square, and it equaled 144. Okay? So it's saying, all right, that's your area, 144. All right? You need to determine if the area of that square has a whole number length for its side. Whole number. So 0, 1, 2, 3, 4, 5, 6, 7. One of those numbers. Okay? Well, you find the square root of this. And in that case, it'd be 12. All right? Because 12 times 12 equals 144. But say you had some number such as 108, right? And you're going to square root that. Well, can you square root that? Does anything times itself equal a whole number times itself equal 108? Well, you just do trial and error if you don't know the answer. So we know 7 times 7 equals 49. So let's start it at 8 times 8. Well, 8 times 8, if you know your times tables, that equals 64. That's too small. And 9 times 9 equals 81. Still too small. And 10 times 10 equals 100. It's close, but it's not quite right. So maybe 11 times 11. And 11 times 11 equals 121. So, nope. That's too big. And there is no whole number in between 10 and 11, right? Again, a whole number would be 0, 1, 2, 3, 4, 5, and so forth, all the way to infinity. It would be a whole number. It wouldn't be a number in between. It would be just, it's a number by itself, a whole number, okay? So the answer to this question is no. No, if this is the area of a square, the lengths of its side, right, the lengths of each side are not going to be a whole number. It's going to be some other type of number, okay? But it's not going to be a whole number, all right? And that's pretty much it when it comes to area of a square and finding out whether or not the sides are whole numbers. And that's pretty much it about square roots as well. When you square root something, you're looking for the whole number if you can get it. If the number is a perfect square, you're looking for a whole number, I should say. You can square root something that doesn't have a perfect square, or that isn't a perfect square, but it's not going to give you a whole number. Only perfect squares give you whole numbers. Okay?